How are you today?
Excellent, thank you. So I've started to play around with the idea already, which is that the number one thing that our customers are going to need to know if they're going to deploy APIs, they're going to add on is the system going to be secure? Am I opening up a security hole? So I need to be able to trust OpenText. I need to be able to trust the platform. Can you just start with, high level? Why should our customers trust us?
Right, so definitely should trust us in regards to that. When we do develop new APIs, new functionality, new applications and services, we take it from a twofold perspective. So the way we look at it is a concept that we've kind of become a mantra within OpenText is security by default. So meaning that, like you mentioned just previously, is that before we even sit down and write a piece of line of code, before we get far into the development process, is that security box is definitely there. It has to be checked off. We fully go through all the different avenues that could potentially be there, and we make sure that we hit all the marks before even, like I said, a line of code is written. Then we start to look at what we call our different levels of security, which starts to bring into what our customers are used to seeing from us, right? For all the years we spent on premises and off cloud regarding our authentication and authorization mechanisms, we've brought those to the cloud and expanded that even further. Customers and developers are familiar with our ability to protect, enterprise-grade documentation and confidential documents and things along those lines. And we've really taken what we've learned for those decades of experience with other products and brought that to the cloud.
So you really brought up a good point that I wanted to dig into just in watching Johan's demonstration, as a matter of fact, which is potentially the difference and making sure that we understand the difference between the authorization of the developer to be able to interact with key services and whether or not the developer can still really rely on the underpinnings of the applications that we're delivering for the authentication capabilities, and then right through to permissions and at some point it comes down to permissions, roles, users, groups, etc. Can you touch on, start maybe with authorization of the developer and then move into authentication?
Yeah, so obviously when you're dealing with APIs now, you do have these gates you have to get through, right? So in order to get through those gates and have the access that you need to have and make sure that only you as the developer has access to those APIs, you have to authorize yourself to do so. And that's done through like industry standards with clients and secrets, client IDs and secrets, pardon me, that have to be used in order to make that initial request. And the first request before you even hit any service is actually to get, is get an authorization token. Once you do have that token, Stephen, then you are able then to leverage that token to access the various services and whatnot, whatever you're planning to do, but only for your specific tenant. So what that means is that if you do generate a token for your tenant, someone couldn't take that token or the developer couldn't take that token and access a different tenant or something that doesn't belong to them. We have hard-coded it directly so that when you do access with those tokens, you're only allowed to access what you're allowed to see and nothing else.
Great. And then what about moving over into the authentication side of managing the people that will be actually accessing the applications that we're working with?
Yeah, so that's the flip side of it, right? And that's the concept that we talk about a lot, is that what's the difference between authorization and authentication, right? Authorization is basically saying, what are you allowed to do? And authentication is basically asking, are you even allowed to do anything? So basically, when it comes to our authentication on the OT2 platform, we've actually leveraged our OTDS technology to do that. So we've actually taken what we've learned on-prem, like I've mentioned before, and we're able to take that and adapt it for the cloud and expand it for industry standards. So those industry standards will be things like OpenID Connect and SAML, SCIM, OAuth, all these different things that we can do, and we fully understand and fully get those capabilities so that we get everything covered from that multi-layer. And that also, if I may, Stephen, is that also leads us into those different layers of security that we talked about, right? From your Auth Z, Auth N, as we call it in terminology, your rights and access management, like you mentioned, with your permissions and ACLs, to your data encryption, to your antivirus, and then eventually you start to look at the final layer, which is something that I think that a lot of platforms really look into, is the concept of a perimeter defense. It's like, how do we protect things, or protect our platform, from people even knocking on the door? What do we do about that, right? So that's something that we're actively integrating and working with today.
Great. So you touched on a bunch of things I wanted to dig into just a little bit more. And the first one was encryption. Can you just walk me through the flexibility that we have for our customers to work with encrypted data, ensure us that we've got encrypted data sort of end to end as well, but maybe talk a little bit about key management and what we're doing there.
Yeah, for sure. So what we just saw in the demo that Johan just did, the great demo there, and the other demos we'll see, basically, let's be honest, anything that we see over the next little while for OT2 follows this flow, right? It is the generic flow. It doesn't necessarily mean that because it's generic, it's insecure. It's just that it's very straightforward, but very strong. So the way that it works is, like I mentioned before, a developer would have that authentication token or authorization token. That allows them then to say interact with the storage service. So when we're talking key management encryption, we're talking about our storage service on the OT2 side. So once that occurs, we actually scan the file. We actually use antivirus to scan the file before we do anything else, because we will reject it immediately if it has any malicious malware, ransomware, any of that stuff. We will get rid of it. But after that point, and once it's been secure, now we need to actually store that content within our storage media. So what we do is we take that file as a blob, as we call it, the content blob, and store that within our storage grid. From that aspect and that point, we actually make a call out to GCP key management, which will then obtain the key that was created, Stephen. When you do create your tenant for the very first time, a key is automatically generated for you for all use. So basically we go to GCP, we get that key, and that key is actually stored in memory. And that's really critical, right? We store that in memory. We don't store that flat file anywhere. We don't store it in a database. We don't store it anywhere. We use it just in memory to do the encryption of that file, which is called the data encryption key, which is a DEC is the short form for it. We encrypt that file. Then we use that key that's pulled down from Google to encrypt it again. It's like a key encryption key. Think about it as a key to get the key to get the key, right? So it's super secure that way. As soon as we're done and we're encrypted and it's been encrypted at rest at that point, we immediately remove it from memory, and we will not request the key again until either a download request is requested, a modification, or a new piece of content is uploaded.
Thanks for that. So from my perspective, if I'm communicating with customers, I want to tell them that the developer doesn't need to worry about security. How do we stand behind that?
Yeah, that's always the cliche thing, right? I've actually talked to many developers, and they'll say to us, how much do I have to do? And then we say, you do nothing. No, of course, there is some things that they do have to do. We do have to prove that as such, right? From a customer perspective, obviously, they have to do the things with their client ID and secret to get their tokens and set up their authentication schemes and stuff. That's a given. The rights and access management, that's business specific, right? So that's something that a developer will have to set up. But as I just described, that flow of the data encryption with the keys moving around, with the antivirus, with the secure transmission, that all happens automatically. So, like I said, we retrieve the KEC from GCP. We use it to decrypt the DEC on our side. We scan our files. Everything is secure transmission. All of that aspects is our purpose to handle, because, ultimately, Stephen, we don't want our developers to come in and have to manage any of that, right? They're here to use our services to create value-add applications or other services for their business. And that's it. They shouldn't have to worry about that. No difference than they shouldn't be a master at data transfer or transmission, right? We need to handle that, and we do.
I think that's a pretty good way to wrap it up, by the way, which is we still need to think about security, and security is job one for everyone, I think, these days as well. But we're doing the things that are necessary in the background so that we're making sure that developers are not putting themselves at risk and not putting their organizations at risk. Really, really thoughtful. Thanks very much for our conversation today. Really appreciate it, Justin.